Good morning, everybody. So my name is Mark Watson, and I'm going to spend about 15 minutes this morning just talking you through some of the research that we've done at IHS, looking at future trends in manufacturing. So to start with, we'll actually define what we see as smart manufacturing. There are lots of terms out there, Industry 4.0, as James mentioned, advanced manufacturing, the Internet of Things, the cyber-physical systems. So we'll have a little look first into the definition. We'll then look at three regions and the approaches that they're taking and the initiatives that they've got going on in terms of the future of manufacturing, the changes that they're likely to mean in terms of manufacturing and industries in those countries, and finally some of the inhibitors or enablers that are helping to either drive or slow adoption of some of these new technologies and processes. So first of all, smart manufacturing. I was at a couple of trade shows recently in Germany, and there really is a huge opportunity here for change in the way that manufacturing is done. And this really, I hope, highlights what we see in terms of the changes and how quickly they're likely to be adopted. So first at the bottom there, we see the use of distributed intelligence. So we all know about Moore's Law, the increasing performance of semiconductor technology, the decreasing costs of that technology. So we increasingly see that being distributed not just at a controller level with industry, but much more at the field level as well. So sensors and devices out in the field having that intelligence and networkability. Increased use of wireless and Ethernet technologies is becoming more and more prevalent. So not just the use of field bus technologies, we see more of IP-based technology and the use of that to integrate the factory environment with the enterprise environment. Along those lines, we then see more consumer devices being used within industry. So this could be smartphones, it could be tablets, some of which might be provided by an organization. Others could be bought in by an individual operator and they're using their own device in industry. And they're using these to visualize what machinery is doing or what components are doing. So for the motor manufacturers, it could be that they can visualize some of the sensors on a motor and see whether it's within its parameters, and if not, do they need to go and investigate the reasons for that. Pervasive sensing, so the use of new battery technology, energy harvesting, and again, that intelligence out in the field so that devices don't just forward every piece of information. They're very selective and they know what information is going to be interesting and what isn't. And finally, the top two there, the Internet of Things. So not just connecting machinery or automation devices, but connecting tooling, humans, everything within an environment so that we can track it and improve the efficiency of manufacturing. And big data. So once you network all of these devices, there's obviously a huge amount of information. Big data, it could be the speed of that information, the variety of the information, the amount of that information. Just means that the IT systems that we have at the moment aren't capable of dealing with that and making use of it. So we need to improve that, use new software, analytics to make sense of that information so it can actually be used to improve decision making. So if we take Germany as an example, I'm sure you've all heard of Industry 4.0, the government-sponsored initiative. So why is this being pushed so much? What is this initiative aimed to improve in Germany? So there are a few things I want to pull out. So obviously increase the competitiveness. In Germany, there's a huge base of not just machine builders, engineers, automation component manufacturers. So how can they leverage that knowledge, that expertise in-house to drive that competitive advantage? Through that, how do they improve production efficiency? So how can downtime be reduced? For example, on a certain component, before it actually gets to failure, how can those operators be made aware that that device is becoming close to failure and preventative maintenance be put in place to help improve the uptime of that component? Investment in research and development is a key part of this as well, and knowledge. We have a huge amount of expertise, an aging engineering community. How do we bring new engineers through? How do we bring children from school and colleges, get them excited about engineering, and bring those guys through to actually help push some of these new technologies? Those are the people that are using their smartphones. They're networked all the time. Those are the people that we're going to need to come through as new engineers to help promote these technologies. Germany is also partnering with other regions. So there was a recent announcement that Germany is partnering with China. So they're looking to work more closely together and how best that they can promote smarter manufacturing in each region. There are obviously very different dynamics in those markets, and we'll look at China a little later on. But in terms of Germany, that is a key market. I think at the moment China imports about 80% of its high-value, high-tech components, and Germany is a big part of that. So they want to be involved in the development of the China industrial base. And something else that came out of the trade show that I recently attended was the focus on services. So if you look at the Siemens booth or the Bosch Rexroth booth, there are companies partnering with those guys like Microsoft, HP, NXP, Huawei. So not traditional industrial companies at all, but these companies are looking to get more and more involved in industry and how they can partner with those traditional industrial specialists to improve the networking side, help with the integration, how do they secure these networks. So there's a huge opportunity there for those companies to get involved. And as part of the Industry 4.0 and the Smarter Manufacturing Initiative, there isn't one company that can address every aspect. So it's either partnerships or acquisitions are going to play a really important role in progressing the implementation of these technologies. Something that James mentioned in Bernd's introduction was the establishment of centers of excellence. Cisco in Berlin is establishing one of those at the moment, and there are other, again, automation companies that are using their own manufacturing facilities as an example to their customers of what can be done, the benefits of implementing these technologies. So there obviously is a big investment involved, and companies want to understand what the return on that investment is. The automation vendors themselves are helping to illustrate that with their own manufacturing facilities. And all of this, the batch size one, is around flexibility and customization. So giving customers the ability to tailor the product that they want, and the manufacturing base having the ability to deliver on that and to deliver on it quickly so that customizable products don't take weeks. You know, they can be delivered quickly, and the automation and the technology enables the flexibility to do that. So if we look at the US, the term here is more smart manufacturing, advanced manufacturing, or the Internet of Everything, you sometimes hear it called. There are some similarities here with Germany, and there are some leading associations helping to promote these initiatives. So the Smart Manufacturing Leadership Coalition, the Industrial Internet Consortium, and the Open Interconnect Consortium are all helping to drive adoption of smarter manufacturing, and are looking to develop open standards to help with integration and IP-based communication and the Internet of Things, which I'm sure Bernd will talk a little more about. Particularly in the US, cybersecurity is a huge consideration. As I've already mentioned, the networking of devices, the ability to see what's going on in a particular component or process, that's great, but you need to be sure that that information is secure. Companies in our industry are pretty conservative, and they're not going to invest and they're not going to network these devices unless they're 100% sure that this information is secure. So that has been identified as the biggest challenge in terms of IoT, smarter manufacturing. If we're going to network all of these devices and integrate everything, how do we ensure security? And something else that I picked out earlier in terms of analytics is there's no point networking everything and having all this data if we can't make sense of it all. And that again goes back to the partnerships, these IT service providers, the guys that are specialists in software. The automation companies are using and partnering with those guys to help understand what this information means, how it can be used to improve decision making and overall reduce costs. That's got to be the goal of this, to improve competitiveness, and particularly for the US with the reshoring, to bring manufacturing back to the US from countries like Mexico, China, and to put them at the forefront of manufacturing again. China, so a very different dynamic here to the US and Germany, and they've really focused on two initiatives to date. So the Made in China 2025 is a longer term initiative aimed at making China the world manufacturer. That is their aim. They also have the Internet Plus initiative, which is aimed at integrating IoT, networking, IP-based communication and mobility into manufacturing. So those are the two key initiatives they have. And in terms of the Internet Plus, they're putting a huge amount of investment into infrastructure. I think there's an estimate, I can't remember the exact source, and it's a massive estimate, but there's 800 million internet users in China. So they're putting a huge investment into fiber optics and infrastructure to support that. And that will obviously play a big part in driving more IP-based communication in manufacturing. So they are working closely, as I said, with Germany, and they're looking at other initiatives to learn as to what the US is doing, what is Germany doing. Germany is Industry 4.0, and I would say at the moment China is probably somewhere between Industry 2 and Industry 3. And I know that Rolf will talk a little bit about the different industrial developments and revolutions over time. So China has some catching up to do. And one of the key things that it wants to do is to move itself from being the low-cost manufacturer to a higher quality provider. So China is coming under increasing pressure from Southeast Asia, other low-cost manufacturing centers. China itself has had huge increases in labor costs recently. So they're looking to automate processes through robotics and other automation components to help manage those labor costs and become more competitive with those lower cost regions. And in the process, they will help to improve quality of production. So for example, Foxconn in China, millions of employees, they're looking to introduce robotics into that process to improve quality through the manufacture of their devices and to lower the amount of manual labor that they rely on and move that labor into more skilled roles. All of this is happening within a changing economic environment in China. So as we know, the growth of double digit that we've been used to in China over the last few years has started to slow down. We see that stabilizing around 7%, so GDP around 7% for China going forward. So they want to establish manufacturing along those lines. How can they use manufacturing, bring manufacturing to China? And that will be a key initiative for the government. So how do they invest? Where do they invest? And so far they've put aside a fund of about $8 billion to help drive infrastructure and investment in smart manufacturing. And something that I read last week, 3D printing, again, a part of the Smart Manufacturing Initiative, and China has put forward a goal that they want to have a 3D printing machine in every elementary school within the next few years. So thousands of schools, again, getting children interested in manufacturing and how they might be used 3D technology to improve processes. So, you know, having the ability to manufacture a tool in-house rather than have to outsource that would be a huge advantage to these companies. So how do we see Industry 4.0 and smart manufacturing actually changing things going forward? So we certainly see increasing levels of automation across the board. So whether that's motors, drives, controllers, sensors, we see more and more automation being used in manufacturing going forward. And most of those devices are networkable. So the proportions are increasing, and the proportions that are Ethernet based is increasing as well. At the minute, we probably see 2/3 field bus connected, 1/3 Ethernet. but Ethernet is slowly gaining ground, and we expect within the next 15 years that Ethernet will become the dominant technology. Wireless is still a relatively small proportion of the market, probably in the single digit, 5% type region. And again, with the conservatism in the industry, we only see that increasing slowly over the coming years. Again, that goes back to security as a key concern as well. We certainly see the integration of both the factory environment and the enterprise, and partnerships are helping with that process, with companies like SAP. How do they integrate both so that the processes are better aligned, and not just internally at a company, but also with the wider supply chain. And that goes down to, as well, remote maintenance. So having the ability to see what a device is doing, how it's performing, without having an operator actually physically visit that device. A key part of this in terms of efficiency and managing particularly large process environments. These can be absolutely enormous, and if you've got thousands of sensors, having the ability to monitor those remotely is a huge advantage. Energy efficiency, so particularly in the motors environment, we know that there's a focus on IE3, IE4 legislation, more efficient motors and how these are used. Again, the use of sensors in these devices can help to manage that. And again, the service model, the move from CapEx to OpEx. So rather than just providing a piece of hardware that a company then has to integrate themselves, moving toward an operational expenditure model where it's a service, it's a solution, and that company is supported through the life cycle of that product and not just ship the hardware device at purchase. So some of the enablers and inhibitors to change, certainly legislation will be a key. For example, if everyone has a 3D printer, who manages the copyright of that? If people are able to print their own tooling in-house, who owns that IP? Certainly in some of the developed regions there's legislation to protect that, but in other regions there isn't, so that will be a key concern. Government strategy, we've talked about what's going on in China and Germany specifically, but there needs to be investment behind that and training. Certainly in the US, President Obama has put a huge emphasis on colleges, investment in training, and that will help again to bring new engineers through. If you look at the installed base versus new installations, there's obviously different considerations there. If you have a new greenfield site, you can look at new technology, simulating, prototyping to save a huge amount of time in terms of the setup of that plant. It's very different if you already have an existing facility. How do you start to integrate these new technologies and processes whilst maintaining production? And that's got to be a gradual process of investment which companies will need to consider. And again, a lot of the leading automation vendors are starting to release that type of simulation and prototyping software to help with that change. The macroeconomic environment obviously has a huge impact, and going back to CapEx as well, we saw recently with the huge change in the oil and gas prices, we've seen projects with Shell, Exxon, not cancelled but postponed for a number of years, and we're talking billions of dollars of postponed investment. So the macroeconomic environment has a huge impact on the capital expenditure of these companies and the investment in new technology. So that will play a huge role in the adoption of these new technologies. And also the industries themselves will have a huge influence. As I mentioned, it's about flexibility as well of the manufacturing process. So any consumer-related industry like automotive, food and beverage, packaging, where the consumer has the ability to tailor their products, these are likely to be the industries that lead the way in terms of investment. So to summarize, the importance of partnerships and working together, because no one company can address all of the challenges that are facing in terms of smarter manufacturing. To develop standards and environment of change, and I know a number of the associations are working together to do that, so that there's open standards to help with the integration and IP-based communication. To have common goals between these associations, and to establish the the foundations for this on the technologies that we already have today. So a lot of this is not new, it's not groundbreaking. We have IP, Ethernet-based technology we've had for a number of years. It's making the most of the technology that we have available to us today, creating that foundation before we get to the top level of that diagram where we're looking at the big data and the analytics. We need to establish the foundation for that first. Knowledge and training of new engineers will really help to drive these initiatives, and without those people coming through, it'll be a real challenge for companies to help establish new processes. And they need to fill that gap between the engineers that are retiring, the gap that will create. So colleges, schools, getting children and students to events like today is a fantastic way to get them interested in these technologies. And finally, the confidence to invest. So what is the return on investment? What examples are there out there of these technologies being used and implemented, and what benefits did that have? What cost did it save? How did it improve efficiency or improve uptime? We need to really highlight those instances to build that confidence and to show that this isn't just something that we talk about, it's actually something that is starting to happen and change in everyday life. Thank you very much. Thank you.
Yeah, also welcome from my side. So the microphone is working, thank you. So we saw a lot what the internet and the today's technologies make everything easier. Could you change it to my slides? And faster, but there is one thing which is definitely not easier and faster. That is a copyright issue. And it's not only the copyright issue itself, it's also to document that in the right way. So I would like to ask you, especially you in the first rows, not to take pictures of this presentation, because otherwise I get in trouble with the copyright issues of the pictures. Sorry for that, I have to ask you for that. So, Industry 4.0, why we talk about 4.0 and why it's... Is this one working? Okay. Why we talk about 4.0 and why we see it as an industrial revolution. So what we see is the first industrial revolution was in the end of the 18th century, so 200 years ago, where we have the entrance of steam power in production and enormous rise of manufacturing efficiency. The second revolution was start of the 20th century, so more than 100 years later. And here we have the first introduction of conveyor belts for mass production. So everybody knows about the first T model of Henry Ford, and also in other production, and this was called a Fordism. The third revolution was another 65 years, about 65 years later, in the beginning of the 17th, where the electrification of factories and introduction of robotics and automation leads to a huge gain in flexibility of the assembling lines and also a change in the work. The third industrial revolution, sorry, that was this one, the third revolution 65 years later, and in the 70s, and now we are today, 2015, we see this as a fourth industrial revolution, because all what Mark presented is a prelude for the industrial internet, the integration of the Internet of Things into the manufacturing, and that's just another 45 years later to the third one. How does this industrial revolution looks like? If we go to an example and have here a work floor, you see in the, on this side, the wireless communication between manufacturing and transport units. Then you have the human-machine cooperation. Then a supervision by employees, the autonomous maintenance replacement, and maintenance and services. And all of this is controlled by module-based design, module-based production, visual maintenance, and supply chain management. And this is connected as well to the worldwide internet, the web. And along this side, you have also the customer relation management is connected to the integrated logistics and external service. All of this has to get one to another. And last but not least, the intelligent workpieces carry information about manufacturing steps by itself by RFID tags. What is the driver for this fourth industrial revolution? It's always the same. It's definitely the money. And what we see now is we have a production which has huge units and the actual costs are already optimized, so I would like to take no pictures. Thank you. Where we are going to, what it will be change is a product range. So we come to more customized production, and what we expected is to lower the costs, especially for the customized products. So it will not be a huge saving. Thank you for not taking pictures. With the actual cost for the mass production itself, it's more for the small numbers. And there we see, even for batch sizes of lot size 1. I will skip that. How is this documented? It starts 2013 in Germany with a report of the Forschungsunion. It's an industry science research alliance. And there is indicated 8 fields where we have to work on. According to that, the 3 associations, Bitkom, VDMA, and ZVEI, founded a cooperated project. And in this project, there are also a lot of industry partners. What is the outcome of this project? The outcome of this project is a reference architecture model, Industry 4.0. So if you want to take a picture, this one you can take. Sorry for that. There I have permission. Okay. And this RAMI, how we called it, the reference architecture model, Industry 4.0, is a basis for the communication between the machine, between the different steps of the production. And therefore, we have this published also, and you can get a leaflet afterwards for that from ZVEI. So, last but not least, that's the last slide, where we are right now. We started 2013. We have the cooperation in 2013 with the different associations. And as you followed maybe the press, there was a change in the cooperation. Also, the name changed from Platform 4.0. It's now Dialog Platform 4.0. And the reason is it's not only one ministry still involved. There are 2. It's the Economics Ministry and the Research and Development Ministry. And this starts right now, 2015. So thank you so far for your attention. And I would like to hand over to Bernd Heinrichs from Cisco. He is a managing director for IOE. And he will give us his view, or the view of Cisco of the fourth industrial revolution. Welcome, Mr. Heinrichs.
So, good morning, ladies and gentlemen. So, I don't take any slides, so you can't take any photos. So, that's just made the decision. Let me start like this. 1 year ago, World Economic Forum in Davos, first time that at the initial round table, there were not the economic guys sitting there, but it was really IT decision makers. It was John Chambers, our ex-CEO. Maybe somebody has recognized that we changed our CEO yesterday, but there's a side note. He was sitting there, Marissa Mayer was sitting there, Telefonica, Deutsche Telekom. They were discussing about the future of the industry, about the future of IT and its impact on the world on our world. And there was a clear agreement. We are staying in front of the next industrial revolution, as we heard before, and this has to do with the merging of IT, information technology, and OT, operational technology. And that is not only interesting for all of us, but it's interesting for our customers and where we are giving it to, really to get better in terms of producing things, getting more efficiency out of it, etc., etc. But let me start with a private story about an area of, I would say, the Internet of Things, which are impacting our lives, which you can map onto the industrial space as well, because it includes all the components which we see happening in the industry as well. My uncle, he's 80 years old, he got 80 years old, and he is living in Nice. He moved out of Germany about 17, 18 years ago, and he came back to Germany in my hometown, and he gave a talk to his guests, and he said his first sentence was, "Thank you, Bernd." Everybody was looking at me and thinking, why is he saying thank you to Bernd? He said, you know, Bernd, when he joined Cisco about 19 years ago, he told me, or he gave me the recommendation I should buy Cisco stock, and I did. And luckily, I sold it again about 3 years later and made a lot of money out of it, and I bought a flat in Nice. Now I'm living there. So that was the beginning of the story. And he said also after that, you know, the stock went flat and didn't increase anymore up to now, right? So, but now I'm living in Nice, and each day I'm driving into the city center, want to take a coffee with my wife. So we drive into the city, and I'm starting my app on my smartphone, selecting the closest parking lot. I take it in 2 minutes. I have a parking lot in 2 minutes average compared to half an hour before. That was his first use case he gave, and it has a lot to do with the Internet of Things. Second was, he said, you know, there is digital displays all over the city displaying the amount of emissions coming from cars is reduced by 30% compared to the amount last year. That was a second use case. Third use case is waste management. He talked about the waste collection is happening on demand when the waste basket is stinking or when it is full. All of these examples are about the Internet of Things because it is about sensors, it is about data, it is about processing data, and it is about people who are taking this information or machines taking the information and playing it back. And I get to that later on, but just to finish the story, he said, you know, and this was last year in December, he said, now I know what Cisco is doing. They do something positive because they are involved in the city of Nice in building up these use cases for the citizens. And I understand that IT is improving my life, my work-life balance and all of that. And I should encourage all of you, he said to his guests, buy Cisco stock again. So it increased 30% since then, right? So he's a good broker. If you need recommendations, talk to him. But it's, the story is all about Internet of Things. And the stuff of data, processes, things, and people is the same in the industry, in our view, right? When we talk about Industry 4.0 at Cisco, we took what the guys here in Germany have built, and we have carefully studied it and adapting a lot of that in the factories in the US already. If you nowadays look into Harley-Davidson factory floors, in my view, and I've been there now 2 times with German customers, automotive players, this is one of the most innovative factories in the world. It is using a lot of these sensor technology, evaluating data to make predictive maintenance of the production floor, and really getting to results which are impressive. Did you check Harley-Davidson's success in the last 5 years? Stock went up, sales went up. They can produce a motorbike within 2 weeks, individually constructed to your needs, compared to 2 years in average for a new type of motorcycle 5 years ago. That is Industry 4.0, if you like, or the Internet of Things. What is Cisco's role? Cisco's role is really to get into this market because first it is a huge market and you need to be part of it or you lose as a company, right? We fully believe there is a huge amount of money at stake. We call it the value at stake in the industry, and the manufacturing space, beside transport, utilities, etc., is the biggest space where value is at stake. You can lose or you can win. We believe just in the manufacturing space worldwide there is a number of $5 trillion at stake for companies to win or to lose. And that means automotive players, this means suppliers into the automotive industry, or it means IT companies like us. John Chambers said last year, if we don't adapt to this new industrial revolution, Cisco is gone in 2 years with a 50 billion cash in pocket. So the company is changing, and I give you 2 examples on what we are doing and what is instrumental in the Internet of Things or the Industry 4.0 space. First, we believe in the power of data, and I think we covered it to some extent in the previous talks. Data is probably the most important good of the future, and if you see the explosion of data, you see there is a huge amount of data, but we need to work with the data. I give you 2 or 3 examples. An average utility company is generating 1 terabyte of data per week. A car is producing 300 megabit per second. A plane is producing 10 terabyte per 30 minutes. And I'm excluding entertainment data. This is control data. If you want to develop a driverless car, you need to work on that. And if you want to be in the business of the future, you need to work with the data. One example, CEO of Continental, car supplier in Germany, supplying into the car industry. The CEO said, in the last 5 years, I invested 50% of my R&D in evaluating data, in learning to work on data. And I'd say now, in 5 years from now, 50% of my revenues are coming from data selling. Wow, that is an impressive statement, I guess. I doubt that because there are a lot of people who want to own the data. It's you, it's us, it's the automotive player, it's a private guy, it's a community, etc. We need to figure out who is owning the data, but everybody wants to own the data. For us to be on the forefront of innovation, and this was mentioned by Rolf before, we are establishing innovation centers globally, and we decided to move into Berlin or Germany, and specifically Berlin, to build our innovation center for manufacturing, transport, utilities, logistics in Berlin, which means all worldwide innovations are going to happen here in terms of product adaptations, etc. Why do we do it? Because the world market leaders are here. In the automotive industry and in the logistics space, and we want to work together with them. If you visit us in the Innovation Center, you would see it is totally different than a regular R&D center. It's all about innovating with the world, with global partners. It's an ecosystem of players sitting there. 10% Cisco, 90% external. 90% startups of the externals, 10% big partners. That is what we are doing. And we started about 3 months ago. Now we have 50 startups working with us and about 20 global customers and partners to make the Industry 4.0 happen. And I strongly believe it will be all around data, and the software to develop the data analysis in a lot of cases. Not neglecting the needs of improving the physics, but that is not our play, right? Cisco is going to be on the IT side of the play. That means data and really working on the use cases which we need really to improve the situation of our customers. And that is what we are going to do. Last example I want to give to you, probably the first example of Industry 4.0 in action, when I equal Industry 4.0 with, again, with things, data, processes, and people, Formula One. Formula One, 5 years ago, started already with first implementations of the Industry 4.0 when you cover these 4 components. Each Formula One car has about 2,500 sensors adapted to the engine and to the whole chassis. 250 out of them are attached to the motor, to the engine. They produce data, which is evaluated by a processor on the Formula One car, and its data analysis is giving information to the box, to the operator of the box, and playing it back to tune the engine during the race. That is, for us, it is Internet of Things equaling Industry 4.0 in action. I'm not covering the examples in factories, beside of mentioning Harley at the moment, because the time is not long enough, but I hope I gave you some impression of what we think is the Internet of Things equaling Industry 4.0 and what it means for us and why it is so important.